My name is Adi Saraf. I'm with Exabeam. I'm joined by Arvind, and who's also from Exabeam, and Svetak from Google. So before I start these slides, I wanted to take a moment and talk about what Exabeam does. Exabeam is a cybersecurity company. Our company ingests logs from our customers, and we actually detect malicious activity when we look at all those logs. So we have a lot of proprietary detection logic that runs on these logs and tries to find, things that customers should be interested in or alerted on. So that's the main focus of the company. And we've been running Apache Beam for our detection engine for the past 6 months in production. It was under development for about 2.5 years before that. So we're just starting to see benefits and challenges of using Apache Beam. But today our focus is going to be on how do we track costs with our business and what we do in cybersecurity. So I think the agenda for today is, what is the problem with costs and how did we tackle them? And what did we actually do about tracking those costs? There's several different ways to do this. We've tried a bunch of different things. What we actually landed on, and then how we did the actual cost calculation, what metrics we used, the stack we used to put all this together. And then lastly, just things we learned along the way, things that you could probably benefit from, looking at some of this stuff and applying it to your own pipelines in Beam. So with that, before I actually talk about the problem, I wanted to take a minute and talk about the architecture of our Beam pipeline. So as I mentioned before, we ingest logs, we detect malicious activity, and then we alert our customers. So this is a very high-level architecture of the Beam pipeline. At the beginning, we just read our events from PubSub. We extract the actual log messages from the files, and then we have 3 different proprietary models that we run. Some are numerical models, some are profile models, and fact models. Numerical models are, an example would be if a person logs in twice or thrice a day into their laptop, we want to make sure that they keep doing that on a daily basis. A profile model is something that's unique, that happens once in a while, once in 90 days or once in 30 days. We want to make sure that there's no activity that's happening from some other country or from some other place that they're not supposed to be logging in from. And the fact rules and fact profile rules are very similar. They're just sort of on and off. Is this happening or is this not happening? Those are the kinds of things we track. And then lastly, once we know something malicious is actually happening, we take all of those triggers that come from these 3 different models and we score them. So that tells you how bad is it, right? Like, is it something I need to look into right away, or is it just something I should be aware of that something might be happening? So once we've scored all of that, we send all that stuff to our downstream system that's responsible for alerting and making sure that the customers are informed and they can see all of this stuff in a centralized manner. So that's sort of the pipeline architecture that we follow. And if you can see, it's a very condensed view here, but there's a lot of different steps that are part of this pipeline. And one of the challenges that we have is actually tracking the cost of all of these steps. So one of the main things that we've observed is when data patterns move, right? Early in the morning, Monday morning, everyone logging in, there's a lot of data coming in, and then Friday, 5 p.m., everyone's logging out. So data patterns change. During the day, it's very busy. During the weekends, it's not as much. So one of the things that we really wanted to look at is when we have these 3 different types of models that are running and all these different steps, we want to make sure that the rules that we have and that we're running are optimized in a way that they're not very expensive to run. We also have capabilities where our customers write rules, and those rules are actually run through these models as well. So we want to make sure that the customers are protecting themselves from not writing some rule that's going to be really expensive to run and manage. So some of the things we tackle with that is like hotkeys, data skew. If you have something that is really configured badly in your rule, there's a way to track that. Then you can also figure out inefficiencies in your code by tracking, what you're actually doing in the pipeline. And it also begs the question of, is your business logic correct? Is what you're trying to do in your steps actually intentional? Is that what you actually want to do, or is there some other better way to do these things? So given all of this, we wanted to not only just track costs, but we also wanted to look at all of this stuff. And we wanted more visibility into this. And I think some of the things we tried, I think Svetak's going to go over that.
Yeah, so cool. So yeah, we wanted to basically first define metrics that could actually help us identify critical data patterns, or to measure what we called cost. And when Adi mentioned cost, it's really two things, right? One is your actual data flow infrastructure cost, and two, which is somewhat related but also maybe more critical to the user, is actually like the amount of time that something takes to be processed. And so what we actually used and how we designed this was using what's known as the Beam Metrics API. And so the Beam Metrics API nicely provides a set of metrics that you can effectively, it's just a one-line sort of piece of code that you can insert, and with each do fun, it'll actually report it to cloud monitoring, which we'll discuss a little bit later. So we picked two metrics that we thought would be really useful to help us track cost in this data pipeline. So number one was the count of elements, and this is going to be count of elements per rule, just as Adi mentioned. And the second was the processing time. So how long does a do fun take to run on a specific rule? And we were lucky in some sense because they already had this existing pipeline, and sort of we discussed it, and we saw that the keys were actually already the rules. And so the Beam Metrics API nicely actually reports the metrics per key. So like I mentioned, these custom metrics are actually emitted to cloud monitoring, and we built, like Exabeam already had dashboards on top of that they could use to actually just retrieve the metrics. And so some things we specifically wanted to see were, okay, what rules or elements have low count but also a very high processing time, right? Because that's something that signals a bad sign, maybe a poorly written rule. And then what also has, or what can we use to have visibility into throughput and latency. And so these, we kind of condensed on these two rules that we thought would help us identify that. So in terms of how we actually did this cost calculation, we basically had the total cost of a pipeline, and we were looking at dividing that basically by the count per step. And so when I refer to a step, I'm talking about do funds. So you can imagine, like a couple of slides back where Adi showed the pipeline, you can imagine that, for example, at the extract logs, this pipeline is actually much taller, but for example, at extract logs, I inserted these two lines of codes that was basically taking the metrics, so count and processing time. And then also at something at the bottom of the pipeline like score triggers, I was also looking at taking the same two metrics, so the count and then the processing time. And these are per key. And something, this would give insight because effectively, if you saw that there was a very high processing time and a low element count, and it was kind of consistent across the different layers of the pipeline, that was a fairly bad sign. So you may be asking, okay, why are we using the Beam Metrics API? Because Dataflow actually reports some job level metrics like vCPU, RAM, and shuffle, things like that, if you go to the monitoring page. So these are actually just job level metrics, and they don't actually give extremely granular visibility into sort of what's going on within different keys in the pipeline per se, in this case, rules. And so that's why we felt that the Beam Metrics API was something that could actually more granularly kind of break this down. And so, each element belonged to a specific rule, and we were able to track for that element, the count, first of all, so how many of those elements were there per key, and then also the processing time in different steps of the pipeline. So this gave us a lot more visibility. So it's actually fairly simple to retrieve some of these custom metrics. So this is just a screenshot of the cloud monitoring page in GCP. So you can go to Metrics Explorer. You can actually look at the Dataflow job itself, and then you can look in custom metrics, and you should be able to see the metrics that you've reported. And so because you have this available to you in cloud monitoring, you can do sort of all the visualizations or things you might do with other metrics in cloud monitoring, such as creating dashboards, or you may have external dashboards that actually integrate with this. Cool. So I'll hand it off to Adi to talk about Arvind to talk about what else was kind of in Exabeam stack that they could use to track.
Okay, we saw the matrices being shown on the cloud monitoring. Now, since we have Grafana dashboards used across the firm, we thought Grafana integrate with the cloud monitoring. So the data or the time series that we see here, so these matrices are integrated, and Grafana dashboard that we see here shows actually the inside the different rules that we saw, the model. We have particular rules. It pinpoints, it goes at the granular level, and we can see the mean efficiency of each of these rules here. So if you see something on the top that's a very inefficient rule, either it's an average processing time per event for that time slice is that inefficient, and then we can look into it, and this shows us what are the next steps to troubleshoot. We do have the financial operations team. They have the entire cost occurred for various systems within the firm. So data flow cost is also one part of it. Now, if you want to drill down and see what are the data flow costs that we incurred per rule, we have it in Looker, the entire feed. We have internally these matrices going into our internal telemetry service, and also through this Grafana service, we have the integration with the Looker, and they can see really what are the costs incurred per day on a particular rule and at a very granular level. So, couple of lessons that we learned part of this project was identifying this expense data rules was the hotkeys. So hotkey can be like a key coming in the same key across events and in large numbers. So we have this hotkey problem that we incurred most of the time. There are the configurations and parameters that we can set to see the hotkeys in the data flow and also list the hotkeys. But usually that is at a very later stage. The whole pipeline has already stalled. So we are looking into improvements to see how we can detect these hotkeys. And earlier, I think we had a discussion earlier today too, to see if there is some enhancement that can be done within Beam or in-house, where we can capture these hotkeys and have them sort of like a feedback and get the pipeline from avoiding the stall on the pipeline. So the second lesson we learned, we would want to say here, is the data patterns that we have to generate alerts. So Grafana, the dashboard I showed in the previous slide, is a good example where if there is a sudden spike in the processing time that we have, which was published through the metrics, the custom metrics, the distribution metrics we had, we can have a threshold there and have, for example, an opt-in alert for on-call person to see, and then they can really troubleshoot it and take care of some of the spikes in terms of the processing time. Third lesson would be the visibility into the code itself. So now, since we see this processing time and the number of per counts of events coming in, we know which part of the code is inefficient. So we can deep dive into it and probably fine tune it and optimize it. The fourth thing was driving the business decision itself. So there are all these sort of data patterns that we see. For example, we do see one thing is the actual logic, and the second thing is we can actually look into the different patterns that occur. Maybe you probably go through the logic, find out where the real bottleneck is. The point where I was mentioning about Looker, you actually have the actual cost per rule. Then you figure out which rule can be fine-tuned. We can go back to a system. Probably one good example is we can add filters. We have something called exclusion rule filters to avoid the large number of events coming in. So filter that process. So as we saw in the previous slide, we can fine-tune, the customers or business team can fine-tune the rules. The last lesson would be sort of a public design pattern, as Svetak was mentioning. We could probably come out with something like a common library or a common layer to publish these custom matrices so that we can have that in different steps, in different do funds. So this becomes like a common pattern that we can use. As of today, Dataflow, it consolidates all these matrices at a very high level, the vCPU and the memory is at a very high level. But if you want to go into a more detailed granular level, this pattern can be used. Thanks everyone.